Hi everybody and welcome back to this next episode of Stats for Studs. No, I'm just kidding, just having a little fun on a very rainy day here. So we are going to go on in this very important chapter, Chapter 5, with normal distributions. On section 5.3 is called Normal Distributions Finding Values. It's kind of vague, but in a way what we're doing is we're going to be doing the opposite of what we were doing in the last section, where we were given a boundary and that determined the region, and then we found the area of the region. In this case, we're given a region and we're trying to find the boundary. Okay, so in particular, we're talking about a region under a normal curve with a certain mean and a certain standard deviation, and we want to find. We're given the value of the area, and we want to find the boundary. So we have a special command on our calculator. It's called inverse norm, and so the way that works is we basically input whatever the area is, and then we have to if we input the mean and the standard deviation, and it gives you this. Now, in particular, it depends whether you're talking what type of boundary what type of region you're talking about. Inverse norm assumes that you are trying to find the right boundary of this region. So basically, it assumes that you're giving the calculator the area to the left of this number, and then inverse norm spits out what that number is. So in this case, if this area is A, you would input inverse norm A lambda mu sigma. Now, if you were given, if you want to find this boundary, in this case, the area is to the right of this number x. So the way you do that is you know that the total area under the curve is 1. So if this is A, then this area has to be 1 minus A. And that's why you would input 1 minus A, because that's the area to the left of this number you're looking at. And then if you're talking about a finite area like this, let's say this is a symmetric area, and where symmetric in the sense that this tail and this tail have the same area. Well, you know that this region plus this region plus this region is 1, and these two regions are equal. Okay, so that means that this region plus this region has to be equal to 1 minus A, and therefore each tail has area of 1 minus A divided by 2. So in this case, you would to find this number, you would put inverse norm of 1 minus A over 2. Okay, in this case, you know that this area plus this area would be A plus 1 minus A over 2. If you simplify that, it's 1 plus A over 2, and you input that, because that's the total area to the left of this number that you're looking for, x2. Okay, so it's probably best to just give us a lot of examples here. So let me just find my calculator just for a minute. Okay, I found it. And let's look at some of these examples. Now, this is the standard normal distribution. So remember what that means. That means that mu is 0 and sigma is 1. All right, so we focus this a little bit. In this case, this is the area to the left of z is 57, so we compute inverse norm of 0.5701. And in some cases, in some cases, you can just omit the 0 and 1, and it will assume that you're talking about the standard normal distribution. Okay, so how do you find this inverse norm on your calculator? Well, you go to the distribution button, okay, and it's conveniently right underneath the inverse norm button, and so we enter that, and then in this case, we want to enter 0.57, comma, and then our mean is 0, and our standard deviation is 1, and we just enter that, and we get 0.176. Okay. So so z is 0.176. In this case, the next one we have, this is the area to the right is 0.23, and we know that 1 minus 0.23, I think it's 0.77. So this is 0.77, and we input that, so we compute inverse norm of 0.7701. Okay, and this turns out to be 0.739. Here we have the area, this middle area is 0.80, and because this is symmetric because we have minus z and z here, so we know that these two tails are at equal area, and we know that 1 minus 0.80 is 0.20, so this area plus this area combined is 0.20 divided by 2, so this is 0.10. Okay, so we can see that minus z would be inverse norm of 0.1001, which would be negative 1.8, negative 1.282. Okay. And so that would also tell us that z is positive 1.282. Okay, that's actually a number that we're going to be somewhat familiar with for what we're doing in the next few chapters. Okay, so these were all stuff that involved the standard normal curve. Now let's say if we have a different normal distribution with something a little different. Let's say we have a different mean. Say in this case we have a mean of 45 and the standard deviation of 2.3. So now if we want to find x, we have to replace the 0 and 1 with 45 and 2.3 respectively. So here 0.70 is the area to the left of the number we're looking, so x would be the inverse norm of 0.70, 45, 2.3. Okay. And when you compute that, that's 46.206. Okay. We'll round to 3 decimal places for the time being. Here, in this case, the area to the right is 0.61, so 1 minus 0.61 is 0.39. So that's this area to the left, so we input that. Okay. And so in this case, x is 44.358. And here we can see that here x1, now in this case these are not symmetric because this area is less than this area. So x1 is going to be the inverse norm of 0.12, 45, 2.3. And I don't have room to tell you, I'll just tell you that the answer to that is 42.298. And then what is x2? x2 would be the inverse norm of now what's this region? We know that this region plus this region plus this region is, what is it? It's these three regions add to 1. Okay, so we need to know this region right here. Well, actually, we know that we don't even have to know what this region is because this region plus this region is going to be 1 minus 0.19. So that's 0.81. And that's not this region, but it's this region plus this region. Okay, and that's all that's what we want to enter. We want to enter the total area to the left of the number we're looking for. So this would be 0.81, 45, and 2.3. And just so you know, that number is exactly 47.019. Okay. All right, let's look at the next page, and here's a little more on a practical application. Okay, you say, well, what are we going to use this in the real world for? Well, we use this to find percentiles among other things. Okay, because we can sort of interpret this area as not just probability, but we can interpret it as parts of the population. And so when we say, in this case, if we say we suppose the heights of the U.S. women ages 20 to 29 are normally distributed with a mean of 64.2 inches and a standard deviation of 2.9 inches. What we're really saying is we can think of the height. When we say the heights are normally distributed, we can talk about the random variable of picking a random height at random and seeing what it is. And then the probability distribution of that random variable can be determined by this normal curve. Okay, so in this case, the mean would be 64.2 with a standard deviation of 2.9 inches. Okay, so now what are we actually talking about when we talk about percentiles? So we can see that when we want to find the 90th percentile, this is going to be a little bit different because we're not necessarily talking about, well, we're talking about finite sets, but we're talking about very large finite sets, very large populations. The thing here is that we don't want to know like exactly how many heights are less than a certain number. What we really want to know is, well, like, what is the cutoff? We want to cut this region into two parts, where one region has area 0.95, and then the other region would be 0.05. Okay, so what we would do is we're actually trying to find this boundary here, and that may or may, there might be a woman having that exact height, but it doesn't matter. Whatever that number is going to be the 95th percentile, meaning that 95% of the heights are less than this number. Okay, so this would be, so we would use inverse norm of 0.95, and then our mean is 64.2, and our standard deviation is 2.9, okay, and this turns out to be 68.97 inches. Okay. Okay. Similarly, the 43rd percentile would be that we would compute this by inverse norm of 0.43, 64.2, 2.9. Okay, and this turns out to be 63.69 inches. Okay, and again, what's going on here is here's our curve, and 43%. That's a little bit. That's on this side, so we're talking about this. This would be 43% of all the heights. The first quartile. Remember, this is the same thing as the 25th percentile. All right, so we have a situation here where we have 0.25. So we use inverse norm of 0.25, 64.2, 2.9. And this turns out to be 62.24 inches. The upper 15%, okay, the upper 15%, we're talking about this area, would be 0.15, so the area to the other area would be 0.85, and then that would be what we want. So this would be inverse norm of 0.85, 64.2, 2.9. Okay, and this turns out to be 67.21 inches. So 15% are above this, are higher, are above this height, and then the middle 60%. that's this. If this middle region is 0.60, then this region is 0.20, and this region would be 0.20. Okay, so we call this x1 and x2. x1 would be inverse norm of 0.20, 64.2, 2.9, and then x2 would be inverse norm of, what would this be now, the total region? That would be 0.20 plus 0.60, that would be 0.80, or the 80th percentile. So this would be 64, it'd still be 64.2, 2.9, and this is, the first number is 61.76 and 66.64. So that would mean that 60% of the heights are between these two numbers. Okay. So, well, it'll be a little easier and you get a lot of practice. Just remember, it helps to draw pictures. Okay, draw pictures and see your boundaries. Okay, and remember, you're always want to find what's the total area to the left of the boundary that you're trying to find. On that note, have a good day, everyone. See you next time.